Good afternoon, AP Bio students. This is Mr. Ebb talking about our next statistical test, which is called the student t-test. To introduce the student t-test, we did an activity today called the reaction something. I'm blanking on it here. Let me go over and share the screen. One moment. So as I scroll down, I'll find what I called the stupid thing. The reaction time test, right here, ST6. That's what we did in class today. So if I open this up, you can see there's places to type in your responses as we go along. So what we're looking at in this particular test is, does texting on a phone interfere or reduce your reaction time? Is essentially what we're going to be doing. So we came up with a research question. Does texting on a phone reduce reaction time of, and our test subjects were ourselves, so we're going to say Homo sapiens, which is the, of course, scientific name for humans. Does texting on a phone reduce reaction time of Homo sapiens? We would then form a null hypothesis. The null hypothesis, remember, states that there will be no effect. So our null hypothesis would say that texting has no effect on the reaction time of Homo sapiens. And of course, we're trying to reject that in our experiment. And if we can, we consider the alternative, which says texting will have an effect on the reaction time of Homo sapiens. Yes, I can type. That should be a period, not a question mark. And so you would fill in something to that effect. And so what we're trying to answer is this question: does texting on a phone reduce reaction time of Homo sapiens? So we're going to be doing two trials. One trial you will not be texting, and in the second trial you will be texting. When we get to the texting part, you're going to text this sentence right here: the quick brown fox jumps over the lazy dog. This sentence was picked because if you actually look at it and work through it, you'll find it contains all 26 letters of the alphabet. So to do this, we had to upload a program into our phone. It's safe. I've used it for years. Nobody's ever had a problem with it. You can take it right back off. Let me show you. Whoops, sorry, let me show you. Unfortunately, this only works on an iPhone or an iPad. It's this program called Reaction Test Pro. Reaction Test Pro. And it's got the blue arm with the pointing finger. And when you open it up, it basically has these two buttons. It's a very simple game. You're going to hit start, and you're waiting for that to turn green. As soon as it turns green, you want to hit the stop button. Boom. And then it records the time it took to stop, which my time was terrible that time, 1.2 seconds. And it will give you a 3-game average. So then you just want to play it again and make sure you play it at least 3 times to the 3-game average. And those you'll record in the data table. If you do not have access to an iPhone or an iPad, let me know and I will see what I can find as a workaround to see if I can find something that might be similar on Android. Let me go back to the screen. So you'll record your reaction time without texting, 1, 2, 3. And the mean is already given to you on the machine, so you can record the mean for yourself. There's 4 of you guys in AP that are on virtual, So I'm going to ask you to share your data with each other to get the group data. And then you can calculate these different values. You may use a spreadsheet to do that if you so choose. The second time through, you're going to do the exact same thing, only this time you're going to have a second phone. So you need to borrow your brother's, your sister's, your mom's, your dad's, whoever's. So you have one phone where you're playing the game, and you have the other phone in your hand, and you're trying to text the message, "The quick brown fox jumps over the lazy dog." So the key is, as you're texting, you're also trying to focus on the game and hit the stop button as quick as you can. And we want to see, will that increase your time, not really alter your time or reduce your time. Hopefully that makes sense. So you are doing the texting and trying to stop the game at the same time. Again, I'll ask you guys to share that with each other. And again, if you don't have a way to get to the Reaction Test Pro, let me know and I will help you out. Then the other thing is you need the class data. And my fault, I messed up on this today. I kept in my head saying, I got to get a picture, I got to get a picture. I forgot to take a picture of the class data today. So I will have to share that class data with you tomorrow. So don't worry about it. If you can get this done, if you can get this done by Wednesday, that's fine. Even if it says it's late, it won't be marked late. So the class data, unfortunately, I forgot to take a photo today. We'll add your data into the class data, and then as a class, you'll calculate these values. Again, you can set up a spreadsheet if you so choose. Hopefully that's making some sense. So then we're going to go and do what's called the t-test. Right? It's really not that complicated, and it's really just plug in the values and go. So let me bring up a whiteboard here. I'm going to stop sharing that, and I'm going to bring up a whiteboard. So the formula for the t-test, right? Now the t-test is a test that is going to confirm whether there's a significant difference or not. And what we are calculating is t, what we call the absolute value, ABS, t absolute. And we're going to compare that to a given value, which is called t critical. If your t absolute is greater than your critical t, you're going to reject your null hypothesis because you are sitting outside that 5%. You're out on the edges of the standard normal distribution curve, and this doesn't make sense. But if your t absolute value is less than your t critical value, you'll be within 2 standard deviations of the mean, and you will fail to reject the null hypothesis. So what you're going to do is you're going to take the absolute value of the mean of sample 1 and subtract the mean of sample 2, and you're going to divide that by s squared. S squared, remember, is the variance of sample 1. That 1 means it's from sample 1, divided by the sample size of sample 1, plus the variance in sample 2 divided by the sample size of sample 2. Those two numbers don't necessarily have to be equal. And you're going to take the square root of that whole thing. And so that's the formula for calculating t absolute, which you're then going to compare to t critical. So I'm just going to plug in some numbers that I made up and just show you how you would do it. So let's say we looked at the group data, and for the group data, let's say our first sample without texting, let's say our first sample that we responded fairly quickly in 0.253 seconds. And we are going to subtract the mean for with texting. Let's say with texting, I increased to 1.173 seconds. So that's just taking the mean from the first sample and subtracting the mean from the second sample. And then I'm going to set that up. And let's say my variance in sample 1 was 0.130. And if I was doing the group data, that was 4 samples. And I'm going to add that to the variance in sample 2. Let's say that was 0.392. And I'm going to divide that by the sample size, which happened to be the same in this case, 4. And now I just have to do the mathematics. So if I do the mathematics here, this is going to give me a negative 0.913, but it's the absolute value of negative 9.3, so it's positive 0.913. And if I calculate this all out, this is like 0.8325. And this one over here, if I do that math, that's like 0.098. And then if I add those two together and then take the square root of those two things, I'm going to end up with a value of 0.361. And then if I take 9.13 divided by 0.361, I'm going to get a t absolute value of 2.54. So that's the key number. That's what I'm after. I'm after that t value of 2.54. All right. So now I have to compare it to the provided table. We haven't got to these tests yet, but you'll see certain statistical tests have a critical values table. The chi-squared test, which we'll get into next week, has a critical values table. The Pearson's correlation has a critical values table. And this t-test has a critical values table. So I have to calculate something called the degrees of freedom, DF, degrees of freedom. For the t-test, and it's different for each of them, for the t-test, to get the degrees of freedom, you are taking the size of sample 1, just mess that up, let's say that's N1, and we are adding the size of sample 2, and then we're subtracting 2. So in this case, it'd be 4 plus 4, subtract 2. And if we carry out the math, we have a degrees of freedom of 6 in this case. So let me go back to the other document. And so here's my critical values chart. It's provided. Here's my degrees of freedom. And I'm going to 6. There's 6. The value is 2.45. So that's my T crit, my T critical value of 2.45. I'm going to switch again. Go back to my whiteboard. So T critical equal 2.45. So now I compare the two values. Well, in this case, T absolute is 2.54. T critical is 2.45. It's just barely greater, but it is greater than 2.45. Therefore, we would reject our null hypothesis, which would say that there is a significant difference between texting and not texting. This would support the laws that are in place for texting, for no texting while driving. If this value had been lower than 2.45, that would have put us into the norm of the curve, and we would have failed to reject the null hypothesis. That would say any differences we're seeing in reaction time is just simply due to chance and error. But instead, it's saying this is not just due to chance and error. There is an impact of texting while trying to do two things at once. And that's sort of where this T value comes into place. So the other thing that I want to show you is how do you do this on the spreadsheet? Right, so how do you do this on the spreadsheet? Because it's a little bit different. So I'm going to go back up here, statistical formulas, open that up. All right. And here is the t-test down here. You see there's a lot more information you have to put into the formula. So I put down here what that is. You have to put in the range for sample 1. So in this case, I'm saying sample 1 is in boxes 1 through 10 in column A. Put in the range of data for sample 2. In this case, I'm saying it's in column B from boxes 1 through 10. Then you have to put in the tails. The tails, for almost everything we do, it's going to be 2 tails. We're interested in both the low end and the high end of the curve. So then it's 2 tails. But if you were only interested in one end of the curve, you were only interested in 1 tail, you would put in 1. So if you were doing a medical study and you were only interested in the number of people that had negative side effects, you might only focus on the 1 tail, the negative end of the curve. In this case, we are interested in reaction times that were both greater and less than without texting. So we have 2 tails. The final number is it paired or unpaired? Paired means the data came from both sets of data came from the same set of organisms. So in this case, this is a paired test for us because the data came from the same set of humans. However, if we had done half the class did the no texting and the other half of the class did the texting, it was 2 totally different groups that created the data, then it would be an unpaired test. I'm not going to go into the equal variance and unequal variance yet, but for now, you're going to basically be choosing a 1 or a 2 in your t-test. So let me pull up an old spreadsheet. And so here's an old spreadsheet. I'm going to take this out. So on the t-test, I've got plants versus no plants. This was a scenario where an aquarium was set up with plants and an aquarium was set up with no plants, and we were monitoring some type of variable. And so I'm going to click the box I want to put it in. I'm going to put equal t-test. Here's the t-test right here. If I hit this, it's going to set it up for me. So my first range is B2 through B11. My second range is C2 through C11. It's telling me 2 tails, which I do want. And it's telling me in this case that it's an unpaired set of data, which indeed this was. These were separate tanks set up with separate organisms. If it wasn't, if it was paired, I could go in and change that to a 1. But I'm going to keep that a 2. And then all I do is hit return. And it gives me the value of 3.41 with the exponent -4. So if I do that, that's basically the decimal is going to move 4 places to the left. So that's 0.000341, which I'm putting right over here in this box here. That is not the t absolute value. This is what you got to understand. On the spreadsheets, it does not give you the t absolute value. So you're not taking this value and comparing it to the chart. What it's giving you is giving you the percent probability. And this is telling you this is well below 5% probability. Remember, the tails make up 5% probability. This is well below 5% probability. And you would reject the null hypotheses. There is a significant difference. So if it's less than 5%, that means it's out in those extreme ends, you reject the null hypothesis. There's more than chance going on here. If that number was greater than 5%, greater than 0.05, 5% would be 0.05. If it was greater than 0.05, greater than 5%, you would fail to reject because it's going to fall within 2 standard deviations. So just realize there's a couple other variables you have to put in. You got to put in the tails and whether it's paired or unpaired. And then what you're getting is the percent probability. 5% probability is the threshold. If you can get greater than 5%, you fail to reject in this case. If you're less than 5%, you reject the null hypotheses. So hopefully that makes some sense as well. So you're going to, for one of your assignments, you're going to complete the reaction time, but that'll be delayed because I have to get you the class data. And you are going to also go in here and create this, do the student t-test assignment. Right? You might want to take a moment to read through the document. There's 3 sample problems and there's a blank spreadsheet for you to put all of your information on to answer those 3 problems. You could put all your math there and you can put your written answers there as well. If you prefer to attach a Google Doc for the written part, that's perfectly fine too. So notice that is due on Wednesday morning. I'll give you a little extra time on the reaction time activity. In fact, let me do that now. I'm going to change that to tomorrow night later. So I'm going to make that 11:59 p.m. So that gives you a little bit more time to finish that off. So you need to finish off 4 and 5, ST4, ST5, not 5, I'm sorry. You finish off the reaction. Let me gather my brain together here again, sorry. You need to finish off ST6 and ST7. ST6 and ST7, and the lengthy movie. Again, I'm told if you have the app on your phone, it gives you more control as to being able to stop, pause, and pick back up, or just be prepared to keep the tab open if it's on your computer. All right. So that should get you in good shape. We will remember to be meeting on Wednesday to touch base on what's going on in class. So thank you for your time and attention. Don't tell me this was, sorry, it looks like I may not have shared my screen.